ओके, तो हमारे पास जो बेसिकली कोड है दैट इज़ फॉर पासवर्ड एंट्री कोड, जिसमें हम एक हेक्स कीपैड यूज़ कर रहे हैं, अलॉन्ग विद दैट एक एलसीडी यूज़ कर रहे हैं, एंड देन वी आर यूजिंग द माइक्रो कंट्रोलर 2560। उसकी सी लैंग्वेज में हम कोड कर रहे हैं इन माइक्रोचिप स्टूडियो। नाउ दिस इज़ द clock rate that we are using in the microcontroller, 16 megahertz. This is the input output library, EEPROM library, the delay that we are using, and because we are displaying characters and there are more than one words, we are using the string library as well. In the place where we are going to add the password, it is at this location. The password that we are using is 2112 and the maximum length is 10. Now, this is the key map, the hex keypad that we are going to use. That it is for that we are putting it in an array, and then this is how the LCD will operate. You can either use an lcd.h library or you can enter the LCD code or LCD display manual according to that. This is the hex keypad that if DDR-B, if port B is at this point, if port B is at this point, this or this. So it is basically checking all of the port B options that we are using in the row and column. Afterward, this is the code for the EEPROM that we are using. What happens if we add the password, whether the password is correct or incorrect, how much length it will have, like it maximum needs to have 8 length. So according to that, we are adjusting the EEPROM. Now entering the main, the character that we have stored, above we stored 2112. Yeah, we stored 2112 above, and the maximum length that we kept was 8. Now, this is where the password will be written, 112. If the password is correct, the access will show that we have been given the access, otherwise, it will be denied. The while loop runs because we will be entering the password once. It opens after 3-second lapse, it will close. And then again, we are entering here that what is on the LED. Then if we have entered more than the length of the password, which is 8, it will show 0, otherwise it will run further. And when it runs further, in the end, if the characters are entered according to the restricted 8 length, it will analyze it whether it is correct or not. How will it analyze it? By comparing. For comparing, it will check whether the password that you store 2112, the entered password is equal to that or not. If it is equal to that, it will show access granted. If it is not equal to that, it will print access denied on the LCD. So this is the overall code for the task. Now I will be making the Proteus based on this. From the development board, here we are going to use we are using the mega board, so we are using this. Okay, we need to rename it. Um, okay, now we have renamed it. You can store it anywhere. I'm using actually this location on the desktop, so I will finish. Okay, Now, according to the code, I will be adding the pins and the. So first of all, we need an hex keypad, or just write keypad. This is the keypad that we are going to use. The next thing we need is an LCD. Okay, so this is the LCD that we are using. Now we will also need a potentiometer, that is active. And another thing that we will need is V source. Now after that we will be adding the pins. Okay, let's now label the pin. According to the code, we set these pins on this PC 0 to 4 and the rest of the pins 7, 8, 9, 10 from the D0 to D4, D0, D1, D2, D3 pins to I21. 20 and 1918. And now these are the pins on D port. So they are in decreasing order. IO 20, IO 19 and 18. IO stands for input, and the number in front of it shows the pin that we are using. Okay, the enable pin is on PC6, and the other RS pin will be on PC7. Sorry, this one is on PC7. The other will be on PC31. Yeah. So RW is grounded. This connection is on IO31. This connection is connected with the potentiometer. This part. VDD is where we supply the VCC, and VSS is grounded. Now these are the connections of LCD, potentiometer, and the voltage. And we are going to connect our hex keypad to the microcontroller. Our rows are connected to B port. So the first port is, we are starting with 0, 1, 2, 3, 4, 5, 6, 7, 8. So first B port is 53, 52, 51, 50. IO 53, IO 52, IO 51, IO 50. Next, here we further we have IO 10, 10, 11, 12, 13. So IO 10, IO 11, IO 12, IO 13. This is all. Now we have made the connections. If we will turn it on, it won't run because there is no code based on which it needs to operate. There are no connections done, no port done, no uh, signal is being given to hex keypad or LCD. We will upload the hex code now. Okay, from here. Sorry, um, this was our open lab. Oh, we didn't debug the code. So here we go, build solution, then debug, start debugging and break. Select the stimulator, again start the debugging. Okay, here we can check it on the register. So the register is being shown below. So these are the registers that are being used. You can use F9 and F11 to further go, because registers are usually taken when we are talking about assembly. In C language, we usually talk about input and output. Switching back to main C, processing status. Um, Debug, restart. Let's check it from here. Check the input out. Currently, we are using wait, here we are using for the input. The hex keypad is basically the input. For that, we are using D port, and for the output, we are using the C port 37, 36, 35, 34, and then D port 21, 20, 19, 18. Okay, these are the input output ports. We said that D port is our input, and we will start with the FN F11. FN F11. F11. So this is in order to check the inputs, and we are using port D and port C for inputs. Sorry, outputs. So for port C, let's restart it. Reset. F11, F11, F11. This is the one operating on the base of and then these are the input outputs. F1, F11. We need to again reset it. You can see the counter cycle and register status changing based on the line that is playing. Now let's upload the hex file again, because earlier we didn't debug it, so there was no hex file there. Back to desktop, then open-ended lab. Now it will be showing the hex file. We updated the hex file here. Start the circuit again, and here we go. You can change the value of potentiometer. Based on the potentiometer, in actual the display changes. It either becomes dim or it becomes dull. You can see here there is no difference. Let's set it to maximum and enter the password. We hard coded the password to 21122112. Pressing the equal will give you the access granted. This will auto reset after 3 seconds. You can also manually reset it, but it is based on auto reset. So after 3 seconds, it is auto reset. Now let's try a wrong password. Access denied. We can try a 4-digit password as well, because our original password is 4-digit. So 3 seconds done. Password is wrong. It should be showing access denied. That is all. Thank you.